Class, we're talking about the adrenal glands, which are also called the suprarenal glands. These particular glands sit on top of each kidney. This gland sits on top of each kidney. So it's like it's added to the kidney, the renal, or supra above the renal. What it is a pyramidal-shaped organ atop the kidney. There are two glands in one. There's a cortex, which is a separate gland from the medulla, even though both of them are together. It is much like the pituitary gland. The posterior came from a separate location than the anterior. So there are two. The adrenal medulla, which is part of the sympathetic nervous system, secreting primarily the hormone epinephrine and a little bit of the neurotransmitter norepinephrine. The adrenal cortex has three layers, but all of the hormones secreted from the cortex are steroids. So collectively, they are called the corticosteroids. The corticosteroids. Okay? We'll go a little further. The three layers of the cortex are called the Zona Glomerulosa, Zona Fasciculata, so glomerulosa, fasciculata, and Zona Reticularis. And then here's the medulla, but that's a different area. Okay, so here's the gland. Let's look at another picture. Here again, here's the capsule. Here's the Zona Glomerulosa cells. Here's the zona right there. You can see F, the Zona Fasciculata, and the Zona Reticularis sitting right there. Okay. As I alluded to, they originated from separate areas. So here's the origination. It's hard to see, but the medulla was an outpouring from neural cells. Let me blow this up just a little bit if I can. So right here, neural cells right here went and invaded into the developing cortex as it surrounds. This is what the cortex actually is coming from a mesoderm setting. Okay. Now, the Zona Glomerulosa produces what we call mineral corticoids, fasciculata glucocorticoids, and the reticularis sex hormones are gonadocorticoids. Okay, let's come here, over here. So I'm going to downsize this a little bit. So steroid hormones are never stored within the cell. They must be produced. When you need them to be secreted, they must be produced. And they're being produced constantly, but the rate depends on the homeostatic need. The rate depends on, but none are stored. Cholesterol is the mother compound. Enzymatic action, remember enzymes guide the direction of all biochemical reactions, would determine what you're going to make. Okay. The Zona Glomerulosa, which is right here, mineral corticoids, and the primary mineral corticoids is something called aldosterone, which you should have seen in I would have presented in the cardiovascular section. Okay. The Zona Fasciculata produces the glucocorticoids, with the main one being cortisol and a little bit of corticosterone. The Zona Reticularis produces androstenedione, which really is an androgen. So this layer really is more involved in androgen hormones that you see. Okay. Right here, not to get all, but here's just looking at the chemical structures of how enzymatic conversions would give glucocorticoids, mineral corticoids, and the androgens we talked about. This chart here. So all of this is by biochemical conversion. We come here. Here's the adrenal gland. The mineral corticoids are produced by the outer layer, glomerulosa, glucocorticoids, middle layer, fasciculata, and androgens, male hormones, reticularis, inner one. And then, as we alluded to, the medulla deals with the catecholamines. The catecholamines, again, in this case, would be primarily epinephrine and some norepinephrine. Okay? So then we go to the mineral corticoids. The main mineral corticoid, again, being main aldosterone. So we come down. So now, aldosterone is okay. Aldosterone is nicknamed the sodium retaining hormone because it holds on to sodium in exchange for potassium. We presented this in the blood vessel chapter when we talked about cardiovascular and intravascular water, okay, and so forth like that there, okay. So let's look at what we have here. And a lot of this aldosterone is tied to the renin-angiotensin. That does not have to be, but a lot of it is tied to the renin-angiotensin system. So let's just look over here for a moment and discuss that in brief, even though we've already discussed it. The liver makes something called angiotensinogen. Renin, which is produced from the kidney, okay, the juxtaglomerular cells, remember in the kidney, produce renin. Renin is an enzymatic secretion that will convert angiotensinogen to angiotensin 1. Angiotensin 1 is converted to angiotensin 2 by something called angiotensin converting enzyme. That particular enzyme is located in endothelial cells of several organs, but particularly the lungs mainly, a little bit of the brain and some other organs. Angiotensin 1 will convert to angiotensin 2. Angiotensin 2 can do several things. Number one, it's a powerful vasoconstrictor, as discussed in the cardiovascular section. Okay. Another thing, it will activate the sympathetic nervous system. Another thing it will do, here we are, is to come in and cause aldosterone secretion. Now, angiotensin 2 is a powerful vasoconstrictor, so it can also cause ADH secretion. ADH, if you recall, comes from the posterior pituitary, okay, posterior pituitary. Now, an angiotensin 2 receptor, if it lies on that, and some areas do have those, can cause some degree of vasodilation, but primarily angiotensin 2 is a vasoconstrictor. This angiotensin 2 aspect is very big in what's going on right now as I'm making this video, the coronavirus and how it works on angiotensin receptors and so forth. Okay? All right. So I go back. So the mineral corticoids regulate electrolytes, primarily sodium and potassium, in the extracellular fluid. Remember, it's the sodium retaining hormone. Importance of sodium affects the extracellular volume, blood pressure, all discussed in cardiovascular. Importance of potassium, aldosterone is the most supported mineral corticoid, and we already talked about that. Okay, so we come here. Mechanisms of aldosterone secretion, renin-angiotensin, which we discussed. Plasma concentration. Potassium has a great effect on those cells to cause aldosterone to be secreted. If the potassium level starts to rise, then aldosterone will come in to eliminate. So it retains sodium in the exchange of potassium. Another that we discussed in the pituitary gland was ACTH, adrenal corticotrophic hormone. Now, it can do something on the zona glomerulosa. Its primary site is the fasciculata with cortisol, but it does have does cause small action there. ANP, you may recall from cardiovascular, it was produced by the atrium, and what it would do is cause diuresis, or also called natriuresis. Natriuresis and diuresis both mean urination. It blocks renin, aldosterone to decrease blood pressure, but it increases the amount of urine output. Okay? All right. So we go here then. Go here. Let me go back. I'll go over here for that one. So here we are with this. Let's just look at this one real quick. So primary regulator, renin-angiotensin system. Decreased blood volume and blood pressure would cause the kidneys to act. The kidneys would produce that renin. The renin then could do angiotensin II in the attempt to try to bring the blood volume back, because by doing this and you get aldosterone eventually, angiotensin II, then you would retain sodium, which would retain water. The other thing is an increase in potassium would do it, because if it's too much of an increase, which we call hyperkalemia, then that would cause this to be secreted and excrete. Stress can do it in the hypothalamus, can cause various things. Stress could induce ACTH. Here's blood pressure again with ANP. Okay, let's go a little further here. So aldosterone hypersecretion due to adrenal tumors. If you had too much aldosterone, then you could have hypertension because you would increase your fluid. Edema, all holding on to sodium, which will hold on to water. Excretion of potassium leading to abnormal functions of neurons and muscles. Potassium is the electrolyte you do not want to mess with. It's only about a 3.5 to 5.5 milliequivalents per deciliter, so it's very small in amount, but it is very important, very important. And remember that aldosterone causes loss of potassium. Okay? Let's go further. The glucocorticoids. Okay? The glucocorticoids, with the primary glucocorticoid, as I alluded to, primary glucocorticoid that I alluded to is cortisol. It's the main one, corticosterone. The glucocorticoids keep blood sugar levels relatively constant. What does that mean? Insulin and glucagon ain't the only things that do this. They're not the only things. Maintain blood pressure by increasing the action of vasoconstrictors. Okay. Cortisol is the most significant glucocorticoid. It's released in response to ACTH, adrenal corticotrophic hormone. Okay. Prime metabolic gluconeogenesis. Gluconeogenesis, development of new glucose. So glucose can be made from fats and proteins. Most of the time you'd have enough, but it can be converted through enzymatic action from fats and proteins. Promotes rises in blood glucose, fatty acids, and amino acids. So it increases blood sugar. See, it's also cortisol is also your anti-stress hormone. So in other words, in stress, you would tend to raise this glucose level. So cortisol, gluconeogenesis, rise in blood sugar, fatty acids, amino acids, okay? Maintains blood pressure, slows the immune. So it's also your anti-inflammatory drug that we brought up in immune, because the SAIDs, remember we talked about the SAIDs and the NSAIDs. The SAIDs, steroidal anti-inflammatory drugs. I'm going to end right here and pick it up again at cortisol.